All right, 9.6. In this lesson, we're going to start looking at the story problems relating to everything we've done in this chapter. Okay, so first one, we've set one up like this already, but for a fundraiser for the math club is publishing a fractal calendar. The one-time fee for publishing is $850. In addition, there's a $325 charge per calendar. How many calendars would the club need to make to have an average cost of $3.42? Okay, so we're looking at finding the average cost. So the first thing we're going to do on this one is we need to figure out the actual cost for their whole thing here. Okay, so in this case, they have that flat $850 fee to publish. Okay, then from there, it all depends on how many calendars they buy. Okay, $325 per calendar. Okay, so if they were to buy one calendar, it's $325. If they were to buy two, $650. Okay, three, $975. Okay, it all depends on how many calendars they bought. Okay, so in this case, it's 3.25 times however many calendars they were to buy. Now, it is saying to find the average price. Okay, so X in our case is talking about the number of calendars. We're trying to find the average price per calendar. So what we need to do is we need to divide by X. Okay, that's how we find the average. Okay, so if you have 5 apples, you spent $5. Okay, 5 divided by 5, that's how many apples we bought. That will figure out the average per apple. Now, in this case, we want that average cost to be $3.42. So this side is representing the average cost, and we want that average cost to equal $3.42. Okay, so that's the setup for these ones. Okay, we had the flat fee of $850 plus the charge per calendar, so $325 times that X. And if we want to find the average per calendar, you have to divide by that X. And we want to set it equal to $3.42 because that is what the average cost that we want. Now, we have a rational equation now we need to solve. Now with these ones, a little bit easier to solve because in order to solve these ones, what we're going to do is multiply both sides by X, which is the LCD, so that we're really doing that same thing. Okay, so multiplying by X, that's going to cancel on the left side, and we're going to get 850 plus that 3.25x is equal to 3.42x. Okay, bringing that x over, so subtracting that 3.25x, we're going to get 850 is equal to 0.17x. Dividing by that 0.17. Okay, we're going to get x is equal to 5,000 if we were to plug that in. Okay, so what that is saying is the number of calendars. So in order to make that average price of $3.42, the math club will have to buy 3,000 calendars. Okay, and if they were to buy more, then they can get that average price closer to that $3.25. The more you buy, the closer you'll get to that $3.25. All right, so similar one, costs $120 for a racquetball membership, plus a $5 per hour court time fee. Okay, so again, let's figure out the total cost. Okay, total cost, you're going to have to spend that $120 just to get that membership, plus that $5 per hour. Okay, so 5x, where x is representing number of hours. Okay, so that's our total cost, and it all depends on how many hours we play. Now, how many hours would you have to play to have an average cost of less than $9? So in this case, average cost, we're going to divide by how many hours we play, and we want that average to be 9. Okay, so then again, we have a rational equation to solve, multiplying by that LCD, which is x in this case. We get 120 plus that 5x is equal to 9x. Subtracting that 5x over, we get 120 is equal to 4x. Dividing by that 4, we get x is equal to 30. Now, one thing here, okay, it says how many hours did you have to play to have your average cost be less than $9? Okay, so when we talk about that, when we hit 30 hours, that's getting that average price to be $9. Okay, what I really should have done is we want it to be less than that 9. Okay, so in that case, x has to be, well, when we solve that, x, I flip sides, so since I flip sides, x has to be greater than 30, okay? So we have to go more than 30 hours. Okay, because again, 30 hours is going to get us that average price of $9. I want it to be less than that $9. So in order to do that, we have to go more than that 30 hours. All right, so next one, we're going to not worry about that one. Okay, probably the tougher of the ones. Okay, if it takes a paddle boat 53 minutes to travel 5 miles up a river and 5 miles back. If the speed of the boat in still water is 12 miles per hour, what is the speed of the water? So we've done some similar to this year. Okay, this is our distance equals rate times time. And anytime we had that, we're going to set up a table to organize our information. Okay, so we got distance, rate, and time. And we're just going to plug in what we know up to this point. Okay, so let's talk about upstream and downstream, and we're going to talk about a total as well in this case. Okay, so it took 5 miles up and 5 miles back, which would give us a total of 10. Okay, the upstream distance plus the downstream distance should give us the total. Now the rate, okay, again, this is where it's going to be the same still. Okay, we said the rate of the boat in still water is 12, but then we're working upstream. And again, if you're working upstream, that means you're working against the current. So minus x, which is the speed of the water. And if we work downstream, that's saying 12 plus x. And the last thing it gave us, it takes a paddle boat 53 minutes to travel both up and down. Okay, so what is the speed of the water? We're talking about, let's talk miles per hour. It's going to take, and we have to be in terms of hours. So the total time was 53 minutes, which we'll write as 53 over 60 to put it in terms of hours. Now, that time spot is where it's going to be a little bit different. We've plugged in what we know. Okay, we don't know the total rate. Okay, so what we need to do is we need to figure out those times. So what we're going to do is we're just going to manipulate our distance equals rate times time, and we're going to solve for time. So divide by r, divide by r. Time is equal to the distance divided by the rate. Okay, so distance or time is equal to distance divided by the rate. We have the distance, we have the rate, so the time is 5 over 12 minus x. Okay, distance over rate. So then the time for downstream is going to be 5 over 12 plus x. Okay, so we can get those two things from what we have been given. Now at this point, okay, the time upstream plus the time downstream should equal the total time. So that is where we're actually going to get our equation from. The time upstream plus the time downstream should equal the total time. Okay. And that's how we're going to set up these. Okay, so now at this point, now we have a rational equation. So what we need to do is we need to figure out the LCD. Okay, all those denominators are different. So our LCD is going to be 60 times 12 minus x, 12 plus x. Okay, multiplying our equation by that LCD then. Okay, moving up here. Again, just multiplying by what you are missing. So in this case, you're going to get 60. Well, let's do this. We'll start with our 5. Okay, our numerator, 5 times that 60 times the 12 plus x. Okay, because that's what we were missing, was the 12 plus x and the 60. The next one, we're missing the 12 minus x and the 60, so plus 5 times 60 times 12 minus x And then on the right side of that equation, the 53, we have the 60. We're missing the 12 minus x and the 12 plus x. So that 53 times 12 minus x times 12 plus x. Okay, now we have that one line of an equation. Okay, so we're going to simplify that. So just multiplying everything out to make it a little easier. 5 times 60, we're going to get 300. So I'm just going to make that 300 right away. That's going to be 300. Okay, and then at that point, I'm going to actually simplify the 12 minus x and the 12 plus x. Okay, that's going to get us 144 minus x squared when I multiply that out. Okay, so then that 300 times that 12 plus x, which is 3,600, plus 300x. Okay, plus 3,600 again, minus 300x. Okay, and what you're going to notice, the x's cancel, which will always happen in these cases. Okay, equals that 53 times that 144 minus x squared, which will give us 7,632 if you plug that in, minus that 53 x squared. Okay, simplifying our equation then, we're going to get 7,200 is equal to that negative 53x squared plus 7,632. Okay, I want to make everything positive, so I'm going to bring that 53 over. So 53x squared, and then bringing that 7,200 over, when you subtract that, we're going to get 432. Now at that point, now we have a quadratic. Okay, we've always had a quadratic, but now dividing by that 53, we're going to get x squared is equal to that 432 over 53. And again, in order to undo a square, we take the square root. We're going to get plus or minus 2.9. And if we're talking about time, the minus does not make any sense. Okay, so we can ignore that one. Now, from there, now we have our time. Okay, so again, x is representing the speed of the water. So the speed of the water was 2.9 miles per hour. Okay, because we talked in terms of miles, we put our time in terms of hours, so miles per hour. All right, so those are the ones that are a little more difficult. So if you have questions on that, make sure you let me know. All right, so work rate problems, we've talked about this one already. We're going to break down each person's or each crew, whatever we're talking about in this case, and figure out their rate. Okay, it would take Milo 3 hours to mow the lawn, so we're talking Milo. And Milo can do that one lawn in 3 hours. Okay, when Gene does it alone, so Gene, so you can do it in 2 hours. Now, how long would it take them to work together? So together, we don't know, so that's where we're going to use x to represent that, and x is representing the time to mow the yard. Now again, okay, so Milo can do that 1 yard in 3 hours. Okay, Gene can do it in 2 hours together, meaning we're going to add those two. We don't know. Now again, we have a rational equation. So we have that variable in the denominator, multiplying by the LCD, which in this case, okay, least common denominator, 3 and 2 is 6. You got x. Go. Okay, so then multiplying by the LCD, 6x over 3 plus 6x over 2 equals 6x over x. 6 over 3 simplifies to 2. 6 over 2 simplifies to 3. X over x simplifies. So then we got 2x plus 3x equals 6. Or 5x equals 6. Dividing by that 5, x is equal to 6/5. Okay, putting that in terms of hours and minutes then, making that a mixed number, that's 1 and 1/5. Okay, and anytime that denominator is 5, so 60 divided by 5, that's 12, and we got one part of that, so that 1/5 is representing 12 minutes. So together, they can mow the lawn 1 hour and 12 minutes. Okay, and it would be expected of you to put it in terms of hours and minutes, so make sure you know how to do that. Again, just take the denominator, 60 divided by that denominator, so in this case was 12. Okay, and we had 1/5, so 1 times that 12 gets us 12. If it was 2/5, 2 times 12, that would be 24 minutes. All right, so Pat Martinson needs 6 hours to deliver the mail, so we're talking Pat in the first case. He can do that one job in 6 hours. When a temporary carrier helps, the job is finished in 4 hours. So together, with that help, he can do it in 4 hours. Now, how long would it take the temp carrier to deliver the mail? So the temp, we don't know, so he's the one we're representing with 1 over x. Okay, so to write our equation, Pat plus the temporary can do that job together in 4 hours. So now, LCD, okay, LCD, our common denominator of 6 and 4 would be 12. Okay, and we have that x. So how do I get from 6 to 12? You times by 2, so it would be 2x. Okay, we have the x, so 12, well, it's going to be just plus 12. Okay, 4 times 3 is 12, so times by 3x. So we get 2x plus 12 equals 3x. Solving for that, you're going to get 12 is equal to x. Okay, so the temp carrier would complete the job in 12 hours. All right. Last one then. The volume V of a gas varies inversely as the pressure P on it. Okay, so right there it tells us our variation. The volume V of a gas varies, so V is equal to, okay, and again, we always have to have that constant of variation, which is always in the numerator, so K, and it varies inversely with the pressure, so inversely tells us to divide by that. So there's our model to relate volume and pressure. Now, again, we got to figure out K, okay, when the pressure is 30, okay, so we got 30, and then the volume is 240. So we need to figure out that constant variation. Just multiplying both sides by 30. K is equal to 7,200. So taking that K, plugging it in, our model is V is equal to 7,200 over P. Okay, so that's our equation that we're going to use. Now, find the pressure being applied if there is a volume of 160 cubic centimeters. So now we know the volume, so we're going to plug that in. We know the constant, so 7,200 over P. So our goal in this one is to solve for P, multiplying both sides by P. Get 160 P equals 7,200. Dividing by that 160, get a pressure of 45. Oh, I don't know what that was. 45. Okay, so the pressure would be 45, okay, and pressure was in terms of kilograms per square centimeters, so kilograms per square centimeters. All right, so there is word problems for chapter 9. Okay, a little more difficult for this chapter, so very important that we are doing our homework. 9.6 story problems worksheet. Okay, so that is your homework. Make sure you do that. If you have any questions, make sure to let me know. Otherwise, have a good day.